All right, back to our limit law handout. There are a couple of rules at the bottom that we skipped in the last video. The first is the power law that says if we have an exponent n here, that we can pull that outside the limit. So evaluate the limit and then apply the exponent. We saw this back when we were doing the product rule. We kind of got a glimpse of it. When I was doing the limit as x approaches 7 of x times x, I was really taking the limit as x approaches 7 of x squared. And in the end, we ended up taking 7 and squaring it. All right, so this is essentially what this law says, that if we have the limit as x approaches 5 of x cubed, we could take the limit as x approaches 5 of x and then cube it. So that would just be limit as x approaches 5 of x is 5, and that's 125. All right, so that essentially gives us this power law. It's going to help us in evaluating limits of polynomials. And the last one on the handout is the root law that says if we have some kind of radical, radicals are really exponents in disguise. And so if we had, for example, the limit as x approaches 9 of the square root of x, this root law says I can just pull that radical outside the limit, suck the limit inside the square root. I know the limit as x approaches 9 of x is 9, so this is just the square root of 9. And we get 3. All right, so let's try to take all of our limit laws together and evaluate this limit that's not a function, x cubed minus 3x plus 5, that I'm in the mood to graph. So we'll see if we can use our limit laws to be able to evaluate this limit. The first thing that I see is that I can distribute that limit over addition and subtraction. So I can say that this limit is equal to the limit as x approaches 2 of x cubed. Just distribute that limit over the subtraction. And then over the addition, limit as x approaches 2 of 5. All right, and then I can use other limit laws that I've got. I just got that power rule that said that I could take this 3 and pull it outside the limit. I also know that this 3 constant multiple can get pulled out in front of the limit. So let's write those two steps. So I've got limit as x approaches 2 of x. We can pull that cube outside. The 3 constant multiple can slide out front. Constants can move in and out of limits. So I've got the limit as x approaches 2 of x. And then we've got the limit as x approaches 2 of 5. All right, now we've got this all down into limits that we know how to evaluate. So I know that the limit as x approaches 2 of x is equal to 2. I've got that limit twice in here. And then I've got the limit of a constant. Limit as x approaches 2 of 5 is equal to 5. Limit of a constant is equal to the constant. And then we'll just apply that exponent and that constant multiplier. I've got 2 raised to the third power minus 3 times 2 plus 5. The rest of that's just arithmetic. So I've got 8 minus 6 plus 5. Let's see, that's 2 plus 5 is 7. All right, and maybe as we were going along to get that answer, you had a moment where you were like, wait a minute, what are we really doing here? I had this as my final answer before I did arithmetic. Notice that if I go up to the original limit, all I really did was plug in 2 cubed minus 3 times 2 plus 5. All I did was find f of 2. And the question is, can I just do that? That's much easier than having to justify each step with a limit law. The answer is sometimes you can just do that. All right, so this says if you're dealing with a polynomial, so something with x cubes, x to the fifth, things like this, or a rational function, that's when you divide two polynomials, and you have a number that's in the domain of the function, which means you can plug it in and get an answer. You're not like taking the square root of a negative number or dividing by 0, anything like that. Then you can just plug in. So if you have the limit as x approaches a of a function, if you can find f of a, then that's equal to the limit, as long as we're talking about polynomials or rational functions for now. All right, so let's give this a try. I've got a rational function here, and the theorem on the previous slide says that if you can plug in x equals 2 into this function, then you have evaluated the limit and you're done. So let's see what happens. So I'm going to plug in x equals 2. So 2 squared on top plus 2 minus 12 over 2 minus 3. So that gives me, let's see, 4. I got 2 minus 12. That's minus 10. Or negative 1. That's negative 6 over negative 1. I get a positive 6. All right, so this is the easiest of all possible situations. When you just plug in the number and you get an answer, that's your limit value. All right, so we're going to talk in class about what happens when you try to plug in like this and you get something like 0/0. That's going to be a very special non-answer that we get that requires a little bit of an algebraic trick. So next Zoom class is all about those algebraic tricks.